Here's the thing that genuinely broke my brain when I learned it: the sewing machine. You'd think it pushes the needle right through the fabric and out the other side, like sewing by hand. It doesn't. It can't. And the trick they invented to get around that back in the 1850s is so sneaky it's still used in every machine today. We'll get to it, it's number one. But first, 9 other everyday mechanisms you've touched 1,000 times and never actually understood. Let's count them down. Start simple. The ballpoint pen is a tiny ball, usually under a millimeter wide, sitting in a socket so precise the ball can roll freely but ink can't leak past it. As you write, the ball rolls and picks up ink from the reservoir behind it, then lays it on the paper. It's basically a roll-on deodorant for ink. The clever bit nobody mentions: it relies on gravity and a thick, oil-based ink that won't dry in the tube but dries instantly on paper. That's why old ballpoints skip when you write upside down. Laszlo Biro patented it in 1938 because his fountain pen kept smudging newsprint. Speaking of pressure-sensitive tricks, the next one's in your bathroom. The flush toilet looks dumb simple, but the magic is a thing called a siphon, and you can't see it. Underneath the bowl is an S-shaped pipe. When you flush, water pours in fast enough to completely fill that bend. Once it's full, it acts like a straw. The falling water on the far side literally drags the whole bowl's contents up and over the bend, then sucks until air breaks the chain. That's the gurgle at the end. The same bend holds a permanent water plug that blocks sewer gas from coming back up. Thomas Crapper didn't invent it. Alexander Cumming patented the S-trap in 1775. Next, something that's been keeping time on your wrist with almost no moving parts. This one quietly killed the entire Swiss watch industry. Inside a quartz watch is a tiny sliver of quartz crystal cut into the shape of a microscopic tuning fork. Run electricity through quartz and it vibrates, and here's the beautiful part. It vibrates at an absolutely precise 32,768 times per second. Why that weird number? It's 2 to the 15th power, so a simple circuit can halve it 15 times and land on exactly 1 tick per second. No gears doing the timing, just a vibrating rock and some division. When Seiko launched the first quartz watch in 1969, it was accurate to 5 seconds a month, humiliating mechanical watches. Before smart thermostats, your heating was controlled by a strip of 2 different metals glued back to back, and it's genius. 2 metals, usually brass and steel, expand by different amounts when they heat up. Bond them together, and as they warm, one side grows more than the other, so the strip is forced to curl. Coil that strip into a spiral and the curling becomes rotation, enough to tip a little glass vial of mercury that closes an electrical circuit. No electronics, no battery, just physics. That round Honeywell dial from 1953 worked entirely on metal getting warm and bending. The same trick runs your toaster and your car's blinkers. The can opener is younger than the can by nearly 50 years. Tin cans showed up around 1810. But for decades, people opened them with a hammer and chisel. The instructions literally said, cut around the top with a chisel. Nobody made an opener because early cans were thick wrought iron. The rotating wheel opener we use now wasn't perfected until the 1920s. Here's the mechanism. A sharp cutting wheel pierces the lid, and a serrated feed wheel grips the rim from below and pulls the can around in a circle, while the blade slices the thin top steel. 2 wheels, opposite sides of the metal, doing a slow shear cut. Next up, the little teeth that hold your... Look closely at a zipper and you'll see the teeth aren't hooks. Each one has a little dimple on the bottom and a matching bump on top. The slider doesn't just press them together. Inside it's a Y-shaped channel that forces each tooth to bend slightly and slot its bump into the dimple of the tooth opposite, locking them like tiny puzzle pieces. Going the other way, the channel wedges them back apart. That's why a zip is strong sideways but slides easily. Whitcomb Judson showed an early version in 1893, but it kept popping open. It took Gideon Sunback until 1913 to add those interlocking teeth. Next, the thing in your pocket that opens a lock no one else's key. Every house key works on a 4,000-year-old idea the Egyptians had. Inside your lock are a row of spring-loaded pins, each cut into 2 pieces of different lengths. With no key in, the pins straddle the gap between the rotating plug and the housing, jamming it shut. Your key's jagged edge is a code. Each peak pushes its pin up by exactly the right amount, so every cut lines up flush with that gap, the shear line. Now nothing crosses the boundary, and the plug spins. Pick a lock and you're just feeling for each pin to settle at that line one at a time. Linus Yale Jr. nailed the modern version in 1861. Next, the mirror trick. Here's a problem. In a single lens reflex camera, your eye and the film both need to look through the exact same lens, but they can't be in the same place. The solution is a mirror sitting at 45 degrees behind the lens, bouncing the image up to a viewfinder so you see precisely what the lens sees. But the mirror is in the way of the film, so the instant you press the shutter, that mirror flips up out of the path in about 5 milliseconds. That's the loud clack of an SLR. The film gets exposed, then the mirror drops back. There's also a 5-sided prism, the pentaprism, flipping the image right way round. Next, the brake. You press the brake pedal with maybe 20 pounds of foot pressure and somehow stop